This CFD training package includes 10 practical aerodynamic and aerospace engineering exercises using ANSYS Fluent software. This package is suggested for all aerodynamic and aerospace engineers who will learn CFD simulation in this field at every level of beginner, intermediate, or advanced. We start this training package with 3 simple exercises for beginner users. ANSYS Fluent software simulates the airflow in the 3-dimensional jet intake. Jet engines are a primary and most commonly used thruster in aerodynamics. Every jet engine includes the intake section similar to the present exercise, which is used for subsonic and supersonic flows. Then, as the second practical exercise, 2 different spoilers in opening and closing modes are compared using CFD simulation by ANSYS Fluent software. The car as a moving device has always been involved with airflow, so the science of aerodynamics has helped engineers bring the best performance to the vehicle. Also, the third practical exercise simulates a rotating disc in a room using ANSYS Fluent software. This training aims to investigate the airflow behavior under the influence of the rotational motion of a rotating disc. In this simulation, there is airflow in a computational domain of a room, and in the middle of this room, a rotating disc with a certain rotational speed is placed. Then we continue the training with 3 exercises for intermediate users. In the project number 4, ANSYS Fluent software investigates steady airflow over an airfoil. The airfoil has a shape deformity called the slot, which separates it into 2 parts. A slot in the airfoil industry is used to optimize the airfoil performance, including increased lift force. An airfoil is a streamlined shape capable of generating significantly more lift than its drag. Subsonic flight airfoils have a characteristic shape with a rounded leading edge, followed by a sharp trailing edge, often with a symmetric curvature of upper and lower surfaces. In project number 5, we will investigate the stall by ANSYS Fluent software. In training number 6, the movement of heated airflow over the surface of an airfoil and the surface cooling of the mentioned airfoil using lateral hole air inlets is simulated by ANSYS Fluent software. The heated air enters the computational domain. 2 lateral air inlets are responsible for the airfoil cooling of the blade or airfoil. After 3 exercises about slot, stall, and airfoil cooling, it's time to focus on the compressible flow as advanced exercise for more professional users. Actually, we studied the compressible flow on 3 different cases. In the 7th exercise, a compressible airflow in a wind tunnel is simulated. The effect of drag force on this body is investigated, and the energy model and standard K-epsilon model with the use of standard valve functions are activated. The 8th exercise will simulate a NACA 0012 airfoil in the compressible airflow field. Geometric defining parameters include chord line, angle of attack, leading edge, and trailing edge. The direction of the airflow into the airfoil body is determined by the angle of attack, the angle between the chord and the horizontal direction of the airflow velocity. Training number 9 will study a supersonic compressible flow adjacent to an F-35 plane. The geometry is a 20-meter F-35 inside a 150-meter wind tunnel. The air is considered a compressible ideal gas, and the Mach number of 2 was achieved. As the last practical exercise, we studied the shock wave in a supersonic airflow applying a transient solver as the most expertise product of the CFD training package. Finally, this project simulates the supersonic airflow encountered by a 2-way oblique airfoil barrier passing through a canal. thus investigating fluid behavior and creating a shockwave phenomenon by ANSYS Fluent software. Mach number is a non-dimensional number that indicates the ratio of fluid velocity to sound velocity in the same fluid. This number is usually used when the fluid flow velocity is close to the sound velocity or more. And one of the major uses is aerospace applications. By the way, you can obtain this CFD training package, including 10 different practical exercises suitable for aerospace and aerodynamic engineers at an unbelievable price. The total cost of these 10 learning products separately is more than $600, which you can purchase with only 1/3 of the regular price, equal to $204. To benefit from MRCFD services, including simulation, consultation, and training, contact our experts via www.mrcfd.com.